In this last example, we're going to solve exponential equations, but what you'll be able to tell is that we can't get the bases the same. If we look at a base of 4 and a base of 13, there's no nice base that we can get to get 4 and 13 to be the same. So if that happens, what we can do is use our inverse function, which is our log function. So we can use log or natural log, and the reason we choose log or natural log is because those are the two buttons we can use on our calculator. So let's start first with the natural log, and I'm going to go through both of them with you. If I take the natural log of 4 to the x on the left, to keep my equation balanced, I would have to do the exact same thing on the right-hand side, which is take the natural log of 13. Remember, whatever I do to one side, as long as I do the same thing to the other side, I am not changing the balance of that equation. Now, using my properties of exponents, since I know this x is up here, my property tells me that I can take it out into the front. So I can rewrite this left-hand side as x times the natural log of 4, and that's still equal to the natural log of 13. Now what's happening is I have my x out in front, I got it out of the exponent, and it's being multiplied by the natural log of 4. Well, the opposite of multiplication is division. So I can now go and divide both sides by the natural log of 4. On this side, the natural log of 4 will cancel out, and I'm just left with x. And then on the right-hand side, I can take the natural log of 13 and divide it by the natural log of 4, remembering to round it to the 100th spot. When you plug this into your calculator, make sure you close your parentheses after you type in the 13 and before you hit the division sign. If you plug this in correctly on your calculator, you should get, rounded to the nearest hundredth, 1.85. Please take a second right now and make sure you are plugging this into your calculator the right way. If you did not get 1.85 when you plugged it into the calculator, please let me know and I can make sure to check what's going on. Now, it not only works for ln, we can also test it with logs. And we would use a log base 10 because that's the log button we have access to on our calculator. So just like we did here with the natural log of both sides, we can also do the log of both sides. So I can take the log of 4 to the x, set that equal to the log of 13. Using my properties of logs, that x would still come out in front. So I have x times the log of 4 equal to the log of 13. And then if I divide both sides by the log of 4, I get x equal to the log of 13 divided by the log of 4. Now I'd like you to plug that into your calculator just so you can see that you do get the same answer. So go ahead and plug that in. And when you plug that in and check your calculator, you should see that you also get 1.85. So it does not matter which one you choose, whether you choose to take the ln of both sides or the log of both sides. Now, as we look at letter B, we have e to the 4 minus 3x equal to 6. When you have e as a base, you're better off using the natural log. You don't have to, but it's going to make things a little bit easier at a certain spot, and I will show you that spot as we work through this problem. So I'm going to start by taking the natural log of e to the 4 minus 3x, meaning I have to also take the natural log of the right-hand side, so I get the natural log of 6. Then using my exponent or my log rules, I can take my exponent and move it out to the front. When I do that, I need parentheses around my 4 minus 3x. I need to know that that whole thing is the exponent being multiplied by that natural log of e. If you forget the parentheses, then it looks like only the 3x is being multiplied by that natural log. So be very careful here with the parentheses. And this is equal to natural log of 6. Now the reason I chose natural log instead of log for this one is because of this base e that I had to begin with. Because if I take a look at my problem now, this natural log of e, I want you to think about that for a second. If I just evaluate the natural log of e, I'm thinking to myself, remember there's an e right here as my base, so I'm thinking e to what power is e? And that's 1. So I know that the natural log of e is just 1. So since this is just 1, 1 times 4 minus 3x will leave me with just 4 minus 3x on that left-hand side, equal to the natural log of 6. So it saves me a step of dividing by this on both sides. If you chose to use the log of e, then you would have to, your next step would have to be to divide both sides by that log. But if you ever see the natural log of e pop up within your equations, you know the natural log of e is just 1, and you can evaluate that at that point. Now that we're here, 4 minus 3x is equal to the natural log of 6. We don't want to approximate anything until the very, very end, or your answer will be wrong. So I need to get x by itself. And the first thing to do to get x by itself is to subtract 4 from both sides. And when I do that, I get negative 3x equal to the natural log of 6 minus 4. Then my next step is I need to get rid of the negative 3 by dividing both sides. So I get x is equal to the natural log of 6 minus 4, all divided by negative 3. At this point, now that x is by itself, I can plug all this into my calculator. And I want you to try that. So plug it into your calculator. Make sure what you're plugging in is coming out the same. And then I want to round it to the 100th spot. This rounded to the 100th spot is approximately 0.74. Again, you can pause this, check to make sure you're plugging it in right and you're getting the right answer. Then I'd like you to go take a look at the try this. So there are 2 of them that I'd like you to try. So do them both and then check your answers. You can go ahead and pause it now. If you did the try this correctly, for letter A, you should get y to be approximately negative 0.87. And for B, you should get w to be approximately 0.10. If you have questions on either one of those, please let me know.